Okay, so for this one, it's a little bit more involved than just a triangle. So for this one, we have a seven-sided polygon based on the directions above before, where this is a regular seven-sided figure. So finding our perimeter is not going to be too much of a problem. We're once again going to use our area 1/2 times the apothem times the perimeter. So once again, perimeter is pretty easy, 7 sides at 5.6. So our perimeter is just 39.2. So that part's pretty easy. But finding our apothem is where our challenge is going to be. So we'll draw first, let's draw a central triangle where we have a central angle. And we want to do that because finding the central angle is a little bit easier than going through the n-2 times 180 and all of that to find the measure of all the other angles. You can do that as well. I just find that finding the central angle is a little bit easier. So finding the central angle, we just take the 360 degrees because that's the rule. It forms like a circle, divided by n, equal to 360 divided by 7. So our central angle's measurement is 51.429. Now, just a heads up, this is going to be ugly all the way around. There's not going to be really any pretty numbers at all for this particular problem. All right, so let's go ahead and pull that triangle out so that we can kind of look at him a little more clearly. See if I can draw. There we go. All right, so now we know that this angle here is 51.429. We want to then draw our apothem because remember our apothem is going to go straight down from that point. So here's our apothem. And that, of course, is also over here. I just had to make the triangle bigger so that I can draw and write in it. All right, so we do need to divide this angle here in half. And so when we do that, so 51.429 divided by 2, that's going to give us 25.7143. Now I know it wants us to round to the nearest hundredth. I like to do that at the very end just simply because it just makes it easier to hold on to some of these extra numbers until we're ready to finalize the rounding. So this angle is 25.7143. And like I said, you could have gone and found all of these interior angles of this regular polygon using n-2 times 180 divided by n. And you would have done the same thing. It's just you would have been dividing and finding this lower angle instead of the central angle. But like I said, I just find 360 divided by the sides is a little bit easier. All right, so once again, we have an angle measure, we have an apothem. Now we also, since we dropped our apothem down, we need to find our side measurements, and 5.6, of course, is the whole length. But we need to divide that in half so that we can find each of the parts. So that would be 2.8. So again, all I did was just divide that by 2. Now we have a nice, pretty little triangle here, don't we? And that's what we're going to kind of focus on in order to solve using our trig. All right, so again, it looks like it's going to be, no, let's not use green. Different colors, okay. So this is opposite, and our apothem is adjacent. So we're back at tangent again. So the tangent of theta is going to be equal to opposite over adjacent. So tangent of 25.7143 is going to equal the opposite side of 2.8 over our apothem. All right. Now, this time be very careful though, because when you cross multiply, you're going to get 2.8 equals A times the tangent of 25.7143, and we're going to have to divide that. So we're dividing by the tangent this time. 3. There we go. All right, so now we can plug that into the calculator and we get A equals a beautiful number. Not really, it's very ugly actually. 5.8143. Now we have everything we need. We can come right back up here to our problem. So the area is going to be equal to 1/2 the apothem, 5.8143, and our perimeter of 39.2. Plug that into our handy dandy calculator, and I got 113.96. And rounding to the nearest hundredth, that's probably good enough right there. All right.